So on my previous video, I was right in the middle of making this correction of 4 divided by pi. So that would be 4 divided by 3.143. So that should be 1.273 is how I would properly round that. And so we're in the middle of example 3.3. We've been working on the conversion between circular mills and square mills. Actually, I'm not in the middle of example 3.3. That's where we're headed. I just have an arbitrary example here where we're converting square mills to circular mills. And so I had 500,000 square mills. And I have my conversion square mills to circular mills. And so I know that there are 1.273 circular mills for every 1 square mill. And so 500,000 square mills would be equal to, see here, 500,000 times 1.273, and I get 636,500. 636,500 circular mills. Okay. Now we can move on to example 3.3. And I like example 3.3 because it is a piece of bus. And in my line of work, copper bus is very common. And I'll give you a couple of interesting notes about copper bus. In this example, it is 5 inches wide, and it's a 1/2 inch thick. So in square mills, that would be 1/2 inch equal to 0.5 inches, 500 mils thick. Then 5 inches wide would be 5.0 inches or 5,000 mils wide. And so that area in square mills would be equal to 5,000 times 500. And according to the book, that would give us 2,500,000 square mills. Let's just confirm that with 5,000 times 500. 1, 2, 3, 4, 5 zeros. 2.5, and then that would give us, simplify this a little bit, 2.5 times 10 to the 6th square mills. Then convert that to circular mills, as we just did. Okay, times 1.273 circular mills for every 1 square mill. Units cancel out. We take 2.5. I'll do a little bit of a shortcut here. 2.5 times 1.273 273 gives me 3.183. And I'll add back my 10 to the 6th circular mils. Okay. Now, in this question it says, what's the resistance of a copper bus using a power distribution panel with dimensions indicated, and so we're looking for the resistance. The problem tells us that it's 3 feet long. Go back to our friend here, resistance equal to rho times L over A. We know that rho is 10.37. I believe the units were circular mil ohms per foot times 3 feet over the area in circular mils, 3.138 times 10 to the 6th circular mils. Our units cancel out nicely here again. Plug those numbers. Let's see if we can do it here. 10.37 times 3. I'll hit enter and divide that by 3.138 to the 6th. So I got to add 3 more zeros, I believe. Gives me my number. And I get 9.9 times 10 to the minus 6 ohms, or 9.9 microohms. And there are actually devices out there called micro-ohmmeters. Micro-ohmmeters that you can measure that resistance with. We, in my line of work and doing maintenance and switchgear in the past, that's a test that you actually do. It's a good way to test connections, predominantly, is how you do it. But in this case, it'd be a good example of actually measuring that resistance of that piece of bus. A couple other things that are interesting about bus work that I want to point out. Bus. A rule of thumb that I use, and I haven't too many people really confirmed this. You can figure capacity amp. Let's do amperage rating of about 1,000 amps per square inch. Okay, so if I had this piece of bus up above there, let me just go ahead and grab another picture of it. And I'll drag it down here. If I had that piece of bus, and it is 5 inches by 1/2 inch, that would give me 2.5 square inches. That tells me that that bus is good for about 2,500 amps. And that's an average size rating for bus work in switchgear cabinets. I know you don't know much about switchgear cabinets, but think of a panel board that you might have in your home. There are pieces of bus in there that make up the connections. And in a 200 amp panel like you might have in your home, that bus work might be 2 inches by 1/8 of an inch in cross-sectional area. So, anyway, a little bit about bus work. Okay, I think that concludes what I wanted to talk about as it concerns just general resistance out of section 3.2. I'm not going to get into wire table stuff very much. The stuff that's in the Boylstat book I don't find to be particularly helpful. When we get to, if you take National Electric Code class with me, later on we'll talk about sizing conductors and using the ampacity table from the National Electric Code, and do it that way, which I think is a little more appropriate and accurate way to do it. So this ends the lectures on section 3.2, resistance of general copper or any material conductors of various shapes.